Now, whilst some of you would guess and check this and wouldn't have a formal method of solving this problem, I strongly suggest that you actually have a method, and if you haven't got a method, then you need to use my method. Okay, as I said, the problems escalate rather quickly, and without methods, you're going to be left struggling. So here's the method I would use to solve this problem. As mentioned in my first screencast video, these equations, when you see the equal sign, are exactly in balance, right? So think of in science when you've got the balancing scales, at the moment they're exactly in balance. If you add something to one side, you need to add it to the other. If you take something away, you need to take something away to keep it in balance. If you divide one side by 2, you better divide the other side by 2. You've got to keep it in balance. If you square both sides, you need to do that to both sides so it stays in balance. If you can get that imagery in your head, then algebra becomes quite simple. Because, as I said, if you do something to one, you better do it to the other, because otherwise things fall out of balance, and then you've got a non-equal equation that it's actually effectively called a mistake. If it's out of balance, you've made a mistake. The other thing I talked about is the undoing operations. Very quickly, if you have an operation that is a plus, to undo it, you subtract. Undo, subtract. If you have a minus, to undo it, you add. To undo a multiplication, you divide. To undo a division, you times. And we talked about if you have a square, well, you take the square root, and if you have a square root, you take a square, and maybe one or two others. Then the next step in your thinking is to think about what happened to x and the order things happened. So x was first divided by 3, right? And then 2 was added. You didn't add 2 and then divide by 3. You divided by 3 and then added 2. So the process that you did, the process that things were done to x, you have to undo them in the reverse order. So the last thing that happened to x was 2 was added. So to undo an add, we have to do a subtract, and we have to take 2 from that side and 2 from that side, keeping the whole thing in balance, right? 5 take away 2, 3. And the brilliant thing here is plus 2 take away 2. Okay, now we have a new balanced equation that x divided by 2 is exactly balanced with positive 3. To undo a division of 2, because that's the only, I'm trying to get x by itself, right? To undo a division by 2, I should multiply that side by 2 and that side by 2. Same thing to both sides, thing stays in balance. And the division by 2 times by 2, that's gone. And on the left hand side, I have got x, which now exactly balances with 3 times 2, 6. X equals 6. Always, always, always check your solution. If you put 6 back into your original equation, it should remain true. 6 divided by 3. Thank you. I was supposed to... There you go. So I checked my solution. Straight away I saw something was wrong. I should have... I wrote it down wrong, didn't I? It should have been x over 3. X over 3. And this should have been times by 3. Times by 3. Okay? So the 3's cancel. And 3 3s are 9. Now when I check my answer, put 9 into here. 9 divided by 3. 3 plus 2. 5. It makes sense. So had I not checked my answer, I would have gone to the next question and made a mistake, basically. Good lesson, eh? Check your answers. How about this one? What was done first to the number b? It was times by 2 first, and then what happened? Then it was divided by 3, and my answer was 6. At the moment, these things are exactly in balance. The last thing that happened to the b was it was divided by 3. Therefore, that's the first thing I'm going to undo by multiplying both sides by 3. Luckily, when I multiply the left-hand side by 3, the 3's cancel. It's not really luck. It's the reason I multiplied by 3 was because I wanted to undo the 3. Okay. 2b must, what's 3 6s?
18.
Okay. 2b now is exactly in balance with 18. Notice in here 2b means 2 times b. In algebra you never see any timeses because we leave them out when we push numbers and letters together. How do we undo a times 2? Divide by 2. And the 2's cancel on that side, so we're left with b on the left and 18 over 2. 9. Check your answer. 2 times 9 divided by 3. Here's another one. So I'll do another line of working this time. Okay, there's my problem. Trying to solve. This is why you need a method, don't you? Because you can't guess and check this one. You need a method. The first thing that happened to x was it was multiplied by 5, then it was divided by 4. To undo divide by 4, I times by 4. To undo division, you times. Right? The 4's cancel. I'm left with 5x on the left, and on the right I'm left with minus 4 over 5. Now, and I think I did a step in my head there. It's 1 minus 1/5 times 4 over 1. Multiply across the top, multiply across the bottom, you get minus 4 over 5. There's a times in here. To undo times, divide. Okay. 5 divided by 5, that gets rid of the 5. Left with x. And I've got minus 4 over 5 divided by 5. you could potentially do that on the calculator, but you'll find it comes to minus 4 over 25. Let me just explain that one a bit further. Do you remember we've done multiplication of fractions and we do division of fractions? If you do something like this, I'll turn 5 into a fraction. 5 over 1 is a fraction. Anything divided by 1 is just itself. So I've turned 5 into a fraction. When you divide by a fraction, you can times by the reciprocal. Means flip the fraction upside down and you end up timesing. I got a few frowns. So multiply across the top, multiply across the bottom. Whoops. That should be a 4, shouldn't it? Okay, so and again, you should check your answer. 4 over 25 goes in here. And negative 4 over 25 goes in there. 4's cancel. And the 5 over 25 cancels down to 1 over 5. Or minus 1 over 5. Okay, so that actually works. If you weren't sure how to do that in your head, you could have used the calculator to check your answer.